My name is Mr.Adebanjo. In our last class, we talked about the first theorem in circle geometry that says that the angle and arc subtend at the center is twice the one that is subtend at the circumference. And we use this theorem to solve problem. So in today's lecture, we'll be talking about the second theorem in circle theorem that says that the angle in the same segments are equal. As you can see on the screen right now, and we are having these two angles at the circumference x1 and s2. I'm saying that these two angles are equal. That is, s1 is equal to s2, and the proving is what we have beside the diagram. It's saying that this angle AOB is twice this angle x1, which is what we proved the last time we talked about angle at the center is twice the angle at the circumference. So this angle AOB is twice this angle s1. Also, this angle AOB is also twice the angle s2. So if that's the case, and that's what you're having in this problem, with the lettering in the figure, angle AOB is 2 times x1. The reason means that the angle at the center is twice angle at circumference, and the angle AOB is also 2 times angle s2. The same reason, angle at the center is twice the angle at the circumference. So which means that our s1 is and s2 are equal because they are both half of the angle AOB. So it means that the angle s1 is equal to angle s2. And I want you to take note of one thing, that the leg of this angle, look at this chord AP and this chord PB. It has the same leg with this chord AQ and chord QB. And that is why these two angles are the same, because they are in the same segment. They are in the same segment. That is, this angle in the same segment are equal. S1 is equal to S2. The second theorem we'll be talking about today also is the angle in a semicircle is a right angle. Angles in a semicircle is a right angle. What do we mean by a semicircle? You know that when we have a semicircle, when there is a chord in a circle, when a chord is included in a circle, that means we have a semicircle. Now, if you look at this chord, now you're having chord AOB here now, chord AOB, and look at you're having diameter AOB rather. We have a semicircle when there is a diameter in a circle. Pardon me for that mistake. We have a semicircle when we have a diameter in a circle. Now look at this diameter AOB, and a chord is attached to it or joined to it called AX and called XB. Where these two chords meet, an angle is formed there at the circumference, and that angle is what we are talking about, and that angle is at 90 degrees. So this is the proving, and that this angle here, this angle AXB is 90 degrees because the angle and arc subtended at the center is twice the angle at the circumference. That is, this angle AOB here, this angle here, the one down, is 180 degrees because the angle on a straight line is 180 degrees. So if this one is 180 degrees, then the angle here is twice the angle that is here. So if this one is 180, that means this one is going to be what, 90, and that's what all about this proving. So, and that's the reason why this angle at the circumference is 90 degrees. So we'll be using these two theorems that we just talked about to solve some problem in the next video. We use them to solve some problems and see how we can go about it. Don't forget, we talk about the angle in the same segment are equal, and that's the first this theorem. And the angle in the semicircle is a right angle. So we'll be using these two theorems to solve problem very soon. Thank you for watching.